One of the worries that we have with self-driving cars is that they might disrupt all the expectations that we have on the road. When we're driving, we communicate with other drivers by going fast and slow. And will self-driving cars be able to understand these forms of communication and drive successfully and safely on the road?
With glances, tiny speed shifts, and invisible social rules, we constantly communicate with each other on the road. But getting self-driving cars to understand these social codes is far more difficult than you might think.
Humans have this incredible ability. We can just see something once and we can learn from it. But machine learning systems and the models in these self-driving cars, they need to sometimes see things thousands of times before they'll be able to do them similarly.
And things that seem obvious to us as humans can be surprisingly difficult for a self-driving car.
They can navigate through complex environments or maybe duck and dive between different cars at speed, which might be quite hard for a human to do. But then they can be confused by a child on the road, or sometimes lighting from the sun can blind their cameras, and then the cars are just stuck.
So to study how humans and self-driving cars interact, Barry and his research team placed cameras inside real autonomous vehicles and record everyday traffic. They typically analyze 60 to 100 hours of footage from each system. Not enough to build the technology itself, but sufficient for spotting patterns.
The early versions of self-driving cars really struggled to understand this kind of implicit communication that we have with each other when we're driving. We might, for example, slow down to yield to another driver. The cars couldn't see that. Or we might sometimes speed up a little bit to try and say that we're going to go first. The cars really struggle to see that. They really struggle to understand the social communication, the interaction on the road.
Autonomous cars are often programmed to be as safe as possible to avoid collisions. They will therefore come to a stop whenever a situation becomes uncertain.
If a human driver just stops on the road, you're usually a little bit confused about why they're stopping, and you look around to see why they stopped. Is there a pedestrian in the way? Is there something on the road? So we've been looking at these examples, we call them halting problems, where the self-driving cars just stop, and that causes a lot of confusion for other drivers.
So what role could this research play in driving the future of autonomous vehicles?
The main results there, I think, is to help designers who are designing these systems think about movement, and think about designing movement has been one of the things we've focused on. They have to design these self-driving cars so that they move in ways that other people can understand, other drivers or other road users.
But self-driving technology is moving incredibly fast, and cars are getting better and better at reading human behavior.
So one of the interesting things about the Tesla's self-driving system is it's been trained on Tesla drivers. So for example, if you're in a Tesla in self-driving mode and it's at a light and the light is red, it will slowly nudge forward like a human would, an impatient human would, because it's been trained on other Teslas with human drivers.
So what does all this rapid development mean for research? And what role will it play in the future of self-driving cars?
We don't get any money from any of these car companies, so I think we have that independence, and it's, I think, really important for universities to do this kind of research so that we can actually take a critical view on when and where and why we should have self-driving cars, and maybe when we shouldn't have them.